Here we go. 1.3 Algebraic Expressions. I think, what is there, about 5 pages. It just keeps getting harder as the problems go. So beginning part, there's an addition sign. There's an addition sign. So all you're going to do is put like terms together and simplify it. You shouldn't have to show any work. You should be able to just put the answer down. 7x to the third, take away 3x to the third, gives you 4x to the third. Then you got to look at your 2's. Your power 2, you have 2x squared and a negative 2x squared, so they cancel each other out. You have a negative 11x and a positive 5x gives us a negative 6x. And there's nothing to go with that 3, so you have to put it in. Final answer. First part. You're learning how to add and multiply different polynomials, basically. The next one's a little bit more time consuming. Everything in the first one has to be multiplied by everything in the second one, and you kind of want a pattern. You don't want to just go all over the place, right? Or else you'll forget something. I like showing little lines showing that I did it. You don't have to. I like making sure I'm organized. 6x to the third. And I keep doing the 3x and the 9x, and that makes 27x to the second. And I just keep doing the same one. I don't switch to the 5. I do 3x minus, or multiplied by negative 5, which is a negative 15x. And I show by using arrows. And then I'm just going to change colors to show you that now I'm going to do the 5 and the 2x squared, which gives me 10x squared. Then I'm going to do the 5 and the 9x, which gives me 45x. And then I'm going to do the 5 and the negative 5, which is a negative 25. And then you just put like terms together and you're pretty much done. Let's see, we have no more cubes. So 6x to the third is your final answer. We have 37x to the second. We have a plus a 30x. And we have that little negative 25 at the end. I know you did something like that last year in Algebra 2, but maybe you didn't do something like number 3. It's the exact same concept, right? But it just is a little bit longer and you have to be organized. I'm again showing my arrows. It's a negative r to the fourth. It's a positive 3r to the third. And it's a negative r to the second. And you're only a third of the way done because you have to do the negative 8r and you have to do the negative 2. And I don't know, if you try to switch it around and not have organization, it's hard to remember which one you did. I'm going to change colors. I'm going to do this one and this one now, which makes it a positive 8r to the third. Easy to get your signs mixed up. A negative 24r to the second. And a positive 8r. 2/3 of the way done with this problem. Am I going too fast? Are you guys doing okay? You guys doing okay? Okay. I'm going to change to green now because maybe you're ahead of me. I don't even know. Okay, let's do these two first. It's a positive 2r to the second. I'm going to get smaller because I'm going to try to get it all on one page. A negative 6r, it's going to squish on there. And a positive 2. And that's all you have to do is put like terms together and be done. Some of this stuff isn't hard, it's just time consuming today. I think it's easier than yesterday, but it's time consuming. Yesterday took a few seconds to do the problem. Some of these take a while, so. Final answer, negative r to the fourth. Positive 11r to the third. We got a bunch of r squares. We have 10, what? Did I miss one? No, I did it right, didn't I? Yeah, I did it right. We have 3r to the second. So we have a negative 25, a negative 23r to the second. I did that right? Yes. And then I've got the r's, positive 2r's and a positive 2. That's it on that page, right? Yep. Wow. Okay, the next one, same thing. This times this equals x to the fourth. I'm going to keep doing this one, negative 16x to the second. And now I'm going to do this one, positive x squared and negative 16. Final answer, x to the fourth minus 15x to the second minus 16. I just want to look at something here. Okay. The next one, the square root of x plus the square root of y times the square root of x minus the square root of y. I'm going to do the same thing. The square root of x times the square root of x means that there's two x's underneath, and for every two you have underneath, you can take one out, right? So the square root of x times the square root of x is x, right? X. So that's x. I'm going to keep working with this guy. The square root of x times the square root of y is a negative because you have a square root of x and a negative square root of y. All you can do is put them underneath the square root sign together because there's only one of each of them. You can't take anything out, so you got to put them underneath the radical. And then this guy, again, there's only one of each. You can't take them out, so it's the square root of xy. And then the last one is the square root of y times the square root of y, but there's a negative sign right there. And you know you have two of them, so you can take one out. And these two are nicely, they're identical, except they're opposites. So your final answer is x minus y. If you look at your assignment, this is the 1 through 88, which I have homework to, answer key to pass out, right? I took this one away because I saw that this isn't on the test, so I just thought, let's just take that one away. So I took that one away, but I added a couple more, and these are the two that I want you to add. Number 6 is this, 6a to the third, b to the third, minus 9a to the second, b to the second, plus 3ab to the fourth, divided by 3ab to the second. So basically you have three things on the top, you only have one thing on the bottom, and there's a rule in math that says you can take each one of these and compare it to the one in the bottom to simplify it. So 3 goes into 6 2 times. A goes into a to the third, a to the second. You take away the two b's on the bottom and you take away 2 on the top, so that means you just have a b. And then you just keep doing that. You did those two, and now you have to compare this one and this one, same thing. It's a negative because you have a negative 9. 3 goes into a negative 9 and negative 3. You cancel out this one, you're going to still have an a. You don't have any b's. They're both exactly the same. They're b squares. And then the last one is a plus because this is a plus and this is a plus. The 3's cancel each other out because they're exactly the same. The a's cancel each other out. They're exactly the same. You have b to the second on the bottom, b to the fourth on the top. You should be just left with, bless you, b to the second. Good to go on that one? Bless you. Jeez Louise. Okay, last one. My pet peeve. My favorite problem. Right there, number 7. It's my pet peeve. It's this right here. I'm just going to make it very basic. X plus 4 squared. X plus 4 squared. I hate grading this. I get mad. It turns into this instead of just nicely grading. It turns into, because all they do is, everybody always tries to take the easy way out. The answer is to take everything and square it. There's my final answer, and then I just grade it like this and go, It's how many x plus 4s? 2 of them. So what you should do, it's like a delayed, write it out twice. You have 2 of the same thing. And what happens when you have 2 of the same things? You get x times x, which is x squared, that. Then you have a a 4x and another 4x, which gives you an 8x in the middle. If you see that, I did those two, a 4x and a 4x. And then you get a 16 at the end. And a lot of people just look on this on the testing, well, that's an easy one, it's this. And it's not that, is it? I showed you that it's x squared plus 8x plus 16. So make sure, I would write it out. So I had to show you number 7. Okay, now we're gonna go into the whole chapter right before Thanksgiving last year. You guys learned how to factor right before Thanksgiving. First semester teacher. So, my battery's low. How can it be low when it's plugged in? It's not gonna go to sleep. Ouch. Oh my. Gotta have some fun, right? Maybe it's not clicked in. Oh, it wasn't clicked in. I'm good now. Okay, back. So, factoring. Yeah, this is going to kill you if you don't know how to factor right before Thanksgiving. So, here we go. The first thing in your head when you hear the word factor is what? When you hear the word factor, you always look for what first? Oh, I heard it. Maybe. What did you say?
I didn't say anything.
You didn't say nothing. Very good. Greatest common factor. Whoever your teacher was must have been awesome, huh? Okay, greatest common factor. That's the first thing you do. And she says it's a 5, an x, and a y, correct? 5xy. You take it out. And what do you have left when you take a 5? Goes into 10 2 times. That's it. Because you can check it by using the famous distributive property. And does that work, using the famous distributive property? Yes, plus 3y. Done. They go really fast if you know what you're doing. But if you don't, I mean, there's the problem. There's the answer. There's no work in between. You're thinking this all in your head. The next one, 12x squared plus 14x minus 40. And the first thing you have to say in your head is greatest common factor, and they do have something in common. Sometimes they don't, but they have a 2. That's it. I was thinking of 4, but they only have a 2. They have a 2 in common. 6x squared plus 7x minus 20. And then we have to see if we can factor this, right? 2 sets of parentheses. Well, this will be interesting because some of you got taught this, didn't you? And I don't teach that. So I taught you guys just figure it out, right? Just figure it out. And I just figure it out. I just do process of elimination. I always start with the innermost factors, right? 2 and 3, always. I never start with 6 and 1. I always start with 2 and 3. Doesn't mean it's going to work, but that's what I start with. And then I always start with the innermost factors of that one too, 20, right? And there's only one set of inner factors, 5 and 4. Usually they work. Not every time, but, oh, guess what? I'm going to put the 5 there and the 4 there, just because. And then I'm going to put the plus sign here and the minus sign here. And I took the 2 out. And when I multiply these 2 together, you guys, does that give us the 6x squared that we want? Does the 5 and the negative 4 give us the negative 20? But the big thing is, did we get the right 7x? So I made my kids do this and say, well, this is 15x. And this right here is a negative 8x. So together it made 7x. Some of you did it in your head. Some of you, I made you do the 15x, take away 8x. But we found it. We found it pretty quickly. I mean, some of you will sit there and take the 2 out, and you'll start with the 6x and the 1x. I wouldn't have, because you're not going to get the right answer if you start with the outermost factors. Usually 90% of the time the innermost factors work. So I wouldn't have started with 6x, then it would have taken you longer to come up with the answer. And sometimes you just get lucky, and then maybe you would have did 3x and 2x, but then maybe you would have put the 5 there and the 4 there. And then you would have checked it and said, wait a second, that's 10x, and that's 12x. How is that working? Is that working right? No. So then I just like erasing and trial by error. But then some of you guys learned how to take this times this and put 120 here, and then you're trying to get 7 here, and anyway, that's another way you can do it, but I don't do it that way. So, okay, the next thing, 81x to the second minus 16y to the second. They have no GCF in common, correct? But you have to recognize that this is called a difference. Everybody see the difference in there, the negative sign of 2. Some of you guys can even name it. It's the difference of 2 perfect squares on either side, right? These are the easy ones. You just put the 2 sets of parentheses. 81 is made up of 9 and 9, and x squared is made up of x and x. 16y squared is made up of 4y and 4y. These are the easy ones. You don't even have to do much because they're perfect squares with a plus and a minus in between, right? Yep, these are the easy ones. I like these. The number 8 way up there, it's a challenging one. You got to figure it out. It's like a puzzle. And what a great feeling when you figure out that it works, right? Wow, I figured it out. I tried one time. Somebody behind me tried it 3 times and finally got it. It is what it is, right? You just kind of switch it around until you get it. One more. Let's say you saw 81x to the second plus 25. Let's say you saw 81x to the second plus 25. You notice that now it's not a negative sign, it's a positive sign. It's a sum. It's not a difference. It's a sum of 2 perfect squares on either side. Do you guys remember that from last year? The sum of 2 perfect squares cannot be factored, right? Do you guys remember that it cannot be factored? It can't be factored. Because some of you will do the pet peeve move and do 9x plus 5 and do the 9x plus 5 and think it can be that, correct? Some of you think it can be that, but look what happens. 9x times 9x is this, 5 times 5 is this, correct? But don't you get 45x's and 45x's, which would give you 90x, but that's not even there. Just proving to you that this is prime. It cannot be factored. It's prime and it cannot be factored, so don't factor something that can't be factored. Okay, the next ones, I'm going to come back to that because we've never done this before. This is the first time you've ever seen it. I want to go to this page and then go back to that page. We did these last year, right before Christmas. This was the last section that you learned how to factor. You learned how to factor 4 terms by grouping, if you guys remember. Groups of 4. When you have 4, did you notice this page? This page had 2 terms, 3 terms, 2 terms. We always did 2s and 3s. But what happens when you have 4 terms? If you guys remember, we group them into groups of 2, if you remember. Put parentheses between the first 2, parentheses between the next 2. Do you guys remember doing this right before Thanksgiving? Every teacher did this right before Thanksgiving. You take the GCF out. Not just once, you have to take the GCF out twice, one for each group. And what does the first one have? Looks like just, an A and a Y, right? An A and a Y. Has an A and a Y, so you're going to have a 2Y minus X. So you took an AY out, and you're going to have a 2Y minus X, plus, you can take a 3 out, and an X. They have a 3X in common. When you take a 3 into 6, you're going to have a 2, and you're going to have a Y left, minus X. And they purposely came up with a problem that looks like this, correct? They're not going to make up a problem that these 2 are not matched up. You know you're doing it right. You know you're doing 4 terms by grouping right if the 2y minus x match up. They purposely did that because now you take out the GCF out one more time. Here you took it out here and you took it out here. Here you're going to take it out here, and here they have a 2y minus x in common, don't they? Which is really weird, but they do. They have a 2y minus x in common. This one has an AY left, and this one has a 3x left. And you are done. factoring by grouping, and you did this right before Thanksgiving. How do you know if you did it right and you have extra time on the test? Can I take this first term and multiply it by this first term? Should that be up there somewhere? And then this term times this term, that should be up there. This term, you can easily check it. Every test is 25 problems long. Every test for the college is 25 problems long. You have to finish in this hour the 25 problems. They're each worth 2 points, 50-point test on every test. Except the final is a 2-day final. That's 50 problems long times 2, so it's a 100-point final. And I have to send that away in the mail to the professor, whoever the professor is. So keep that in mind. Every test is 25 problems long. So, okay, the next one. It's again a 4-termer, and you're gonna say to yourself, that's right, it's a 4-termer. I need parentheses, right? But whoever your teacher was might have told you that it's not that easy to do it when the third term is negative, if you remember this from last year. It's not good to have the third term negative, so I purposely rearrange my problem so that my third term is positive. I rearranged the problem to make sure my third term is positive. People have tried to do it, they just don't know what to do. Do we put the parentheses here? Do you put it here? They're really messed up. So it'd be way easier if you made the third term what? Positive. Once you do that, put parentheses there, put parentheses there. The GCF for this one is 2a. If you take out a 2a, you're going to have a 2c minus d. Whoops, plus. If you take a 2a out, you're going to have a 2c minus d. And if you take a b out, correct? And 2c, did I do it right? Yes, I'm doing it right. 2c minus d, 2c minus d. They have a what in common? 2c minus d. When you take a 2c minus d out, you're going to have a 2a plus b left on this one. Final answer. So this is review, everything. Page 1 was review. Page 2, page 3, page 5 are all review from Algebra 2. This is the new thing. You got to memorize this formula. So I want to go back to this, and I want to bring up this. You need to notice on this problem that this was a difference of 2 perfect squares. Everybody see that? Okay, now you're going to see something on this page. You're going to see the difference of a cube and the sum of a cube. You need to recognize it. There's a difference, but on either side it's not a square, it's a cube. And look at the formula. It's a very long formula. And then the sum of a cube. I want to go back to this page. The sum of a cube. Look at this over here. When I did the sum of 2 perfect squares, could you have done it when you do the sum of 2 perfect squares? No, it is prime, but guess what on this page? You can factor the sum of a cube. You can factor the difference of a cube. See the difference between it? But you need to recognize that you have cubes on either side. So instead of teaching you the formula, I'm just gonna go and do a negative one, and I'm gonna do a positive one and show you how to do cubes. When you notice that it's a cube right away, you're gonna say, that's right, I gotta make a little parenthesis and a big parenthesis. I'm not even gonna show you the formula. It'll make sense after I show you the formula. First thing you have to know is this times this times this, 5 times 5 times 5, 3 times is 125. And this is 3 x's, this is 3 2's, it's cubes, right? It's 3 of everything. You have to recognize that. Once you recognize that, you're going to make a little parenthesis and a big parenthesis. You're going to only take one of each of these. Well, I said this was made up of 3 5's. So I'm going to put a 5 here, and I'm only going to take one of these, which is 5x. And I'm going to put a minus sign. And I know that this is made up of 3 2's, and I'm only going to take one of them. So that's going to be a 2. Then here, Well, I already used one of them, and I used one of them, so there must be two more of them left, right? If I already used a 5 and an x, so there must be two, and what does two of them make? 25, right? 5 and 5 make 25. And I know I need two more of those. Well, I already used one of the 2's to make the 8. I still have how many more 2's? 2 more, which makes 4. That goes over here. And then how do you get the middle term for this one? Multiply these two together, and 5x times 2 is 10x. You can see that it doesn't matter. This is always positive. So this one is always positive. If this starts off negative, this is negative. Everybody see that? If this is negative, this is negative. If this is positive, this is positive. This is negative, this is negative. And this sign is the opposite of that one. Do you see that? So it goes negative to positive. Final answer. If you believe me, we could go back to the first section and we could sit there and do this. And a lot of things would cancel out when you did this. There are 6 terms. This times this, this times this, this times this, 6 of them. But most of them would cancel out and you'd only get that left. And if you don't believe me, if you're bored over the weekend, you could sit there and multiply that all out and I bet it's going to equal that, right? So, okay, the next one, I think grand finale. Grand finale. You need to recognize that these are perfect cubes on both sides. This is made up of 3 x's, x times x times x. And you got to know that 64 is 4 times 4 times 4. You just got to recognize that these are both perfect cubes. And when you know that they're perfect cubes on the test, you're going to say, that's right. I just make a what? A little parenthesis and a big parenthesis. Maybe not that big, but you're going to start with only one of them, of each of them going there. It's easier to memorize it this way than to memorize the formula, truthfully, right? Just take one of each. What's one of each? X plus 4. We already used 1. How many more do you have to put here? 2. And you already used 1, so you already have to use the other 2 have to go here. See where we got those 2 from? 16, 4 and 4. But how do we get that middle term? How do we get that middle term? What do you have to do with these 2? Multiply them together. This is always positive at the end. I told you that. You can see that the formula says that. And if this one's positive, this one is a negative. So you don't have to memorize the formula. I think you guys got her down pretty good, don't you? Pretty good? Not bad. So, but you have to recognize that they're perfect cubes. Do you guys want to do one more perfect cubes or you got it? You guys want to do another one? We can do another one. Got it? Okay. Well, you got 15 minutes to start the assignment, right? I think that's it, right? Good? Okay. You have the assignment sheet, but you need answer key, which is right here. I found out through the years that I gave too much homework, so I crossed off some of them. So just keep in mind that I became nicer in my years and I crossed off a lot of things. Oh my gosh, you guys, I used to give them 1 through 87 odds, 40 some problems. Kids were like, wow, I signed up for college, boy. And I didn't know, I mean, then I'm like, wait a second, I gotta tone this down. So. That was a long time ago. On Monday, when you come back, on Monday, it's not up there because it's this week, but Monday, I just decided I'm gonna slow it down. This book does not have worksheets. They don't believe in worksheets. I made a worksheet so that you can review 1-1 over again. You can review 1-2 over again. We can review a little bit on Monday. So on Monday, there's no lecture. We're just gonna review. Go back. Some of you, 1.2 got you crazy. Those negative exponents, you didn't know what you should be doing. So maybe you guys need some more practice. So again, I started putting in a couple of extra worksheets in to slow down a little bit.